Good afternoon. I wanted to make a video on some things that I'm noticing in lab reports. So, technical writing in terms of formats, in terms of how you would write certain sections, and just the basic formatting stuff and organization to help you in writing. Okay. Now, when you are writing or sending me a file, make sure that file name has your name in it. Okay, so that's the first thing I'm noticing. Because if I have 20 students, I don't want to sit there and rename the file to put your name in there. So please put your name in there. Okay, now let me go to this. So here is an example of a lab report. Okay, and I just want to go through this. We've been editing, and I like this. I want to make sure that you understand what you need to do. Okay, so this is a lab on temperature sensors. We're calibrating a thermistor, and you notice over here there's navigation. This is, if you go to View, you can click this navigation pane. Okay, so uncheck it. It goes like this. All right. The cool thing is you can jump to each section. Okay. All right. So these sections are, if you go to Home, these are under Styles. These are heading 1s. Okay. You could also make things heading 2. So let me show you. So for example, in this thing, you could put a heading here. Let's call it heading 2. And let's call it calibration methodology or something. Methodology. Okay. And that creates a heading 2. All right. Oh, I didn't mean to do that. Now, each major heading, you want to make sure that it's on the next page. Okay. I don't know why it did that. Probably because of that. There we go. Okay. Yep. All right. So make sure each heading is on a new page. And accidentally, and I'll show you this here in a second. Whoops. Let me undo that. Okay. So headings, which you can then put in your navigation and you can jump to them. Okay. Table of contents, you can actually create a table of contents. If you go up to, let's see, I believe, is it reference? Yep, references. You can click table of contents on a new page and it will actually create a table of contents for you. Okay. And then you can update that table of contents. All right. So make sure you have a table of contents, abstract. Basically, your abstract and conclusion pretty much are the last thing you do. Okay. Abstract is, in this lab, we're going to do this. And the conclusion is, in this lab, we had done, it's like we've done this. Okay. Now, here's just a quick example of like how you would start it. Now there's many ways you can do this. Okay. So I would start in an abstract. Temperature sensors are heavily utilized in the engineering profession. It is of high importance to correctly measure the temperature in specific devices. Thus, they need to be calibrated. And then you say, in this current lab, a thermistor is calibrated with a thermometer from your temperature ranges. Okay. It's right to the point, and you can you avoid the fluff, if that makes sense. Okay, so technical, get right to the point. Now in here, you never use we, I, us, none of that. Okay, you avoid that completely. Okay. Now, one thing I'm also noticing is I get these in a Word format, and then I go up to here onto review, and I track my changes. Okay, so I click this, so now I'm tracking the changes. All right. What you need to do when I send it back to you is you pretty much need to like highlight the section, go to tracking, see my comments or changes, okay, and then say you can accept and move on. Okay. Now, I didn't delete this. I made a comment. Okay. So what I would do is probably copy this, go over here, make sure you're not tracking anymore, paste it, okay, and then fix like these, right? These need to be under home. They need to go up, okay? All right. So now here's a comment. This says never used. Now, I don't want comments back, so you have to delete this or resolve the thread. You resolve it or delete it and they go away. I prefer that you just throw it in the trash, delete it. So then it's gone. Okay, you can move on. So you can have the comments up if you click on them. Sometimes I just X them off and they're good to go. Okay, so you need to fix this. Now using a voltage divider, comma, all right, voltage, just say voltage data, but you might have to fix this because it doesn't completely make sense, but make sure you have your commas correctly, okay? So this would need to be fixed, and I might just highlight that red. Over here, basically, I have this formatting issue, okay? So, whoops. I would just highlight it, go to View, Review, and then where to go? Go to Tracking, Accept, and move on to the next. Okay, so it accepts that. All right. Now, here's another one right here. Basically, highlight these, Tracking, Accept this change. Okay, so now you've accepted the change, and then you can modify it if you have to. Okay, so see here's there may be some other issues or you might have to accept. All right, and then I put this equation, like again, go to accept, put this equation in, equation 1. Now when you put equations in, make sure you go to insert equation right here. You want to put your equation in, label it equation 1 or 2 or whatever. Then underneath is where you write where R naught is, and you label what it is, T naught and beta should be a symbol. So you want to do symbol and then get the beta symbol, okay? And this W is lowercase. So you define what these variables are in here, okay? Or if you really want to, above introduction, make a nomenclature, okay? Where you define all the variables. It's up to you on that. All right, so equations, again, you can highlight this, go to Review, Tracking, Accept this change, okay? All right, and I got comments here. Make sure you check those comments and you delete those. Down here, all right, figures are centered. Figure captions go underneath and they are centered. And you want to make sure you reference this. So put your reference in, because unless you made it, but I don't think you did because I'm pretty sure this was referenced in the references, okay? So I'll just highlight this. Make sure you reference that, okay? All right. Again, go down here, calibration. Make sure if you create a schematic, there is a program. Let me grab this program real quick. It's a free program that you can create your own schematics with, and I highly recommend doing it. Okay. Let's see. Where is it? Flowchart. Maybe it's this one. Yep. appdiagrams.net. Okay. So right here. So you should be able to see that now. And you can decide later. But here is this basically, here's the website, okay, up here. And then you can create your own schematic, okay? You have arrows that you can, like, say you drag over. You can then search, say you want to make a resistor. You can create a resistor and bring it over. You can rotate it. You can make it bigger, okay? Then you can save this as an image and bring that image in, okay? So make sure you do that. This was done in there, which is great. Make sure you label, like VS is source, RT is the temperature sensor, RF, This should probably be labeled VF because it's voltage across the fixed resistor. Okay. Other things, there is a website that you can pretty much put like a website link, a book title, or an ISBN, and then you click search, and it will actually spit out the MLA format for your references. Okay, so make sure you have that done in there. Cool. Okay, let's keep going on the. We'll leave on the format. Okay, again, highlight these. Go up to review, tracking, accept this change. Okay, and you may have to do it a few times because I may have a few things in there. Accept this change. Okay. Check the comments. The font size might be different. Yeah, make sure your font size is all the same. I think this was 10.5, but up here is 12. So make sure your font is right. I am old school, so that's why I use Times New Roman, but I believe you like Calibra is probably more of what they're using now. I'm not too picky on that. Okay. All right. Materials, that's fine. It's just pretty much bullets. Procedure, you don't do step by step. You say this. Here's the procedure. Here's some constants that we need. We use that voltage divider shown in figure 1 to create this schematic or apparatus. This was done in Fritzing. All right, so let me show you Fritzing. Fritzing is actually a paid app. I lost my key. Where are you? But you can create actual like circuit diagram, actually like circuits that you can run to see how they work. All right, so here's Fritzing. It's a really cool app. You can download it and you can create that circuit. Okay. Projects. Like basically you can create something like this. Not that. Say like this, some sort of circuit, and you can hook it to an Arduino and actually run the program to see if it works. I like it because it creates these simple schematics for you so you can see how they would hook up to a breadboard. Now, the voltage divider in the introduction was made in that program, but you don't know how to hook this up clearly from a breadboard. That's what goes into your procedure. As you're using that voltage divider, here is the data for that thermistor, here is the circuit, and then specifically tell the reader you're going to read the temperature or the voltage across it every 2 minutes. It's recorded, and you're going to go up to this certain temperature. Okay. Here is the actual schematic or setup, so I would include that as well. Okay. Now, results and discussion. Make sure figures have no titles. There should be no titles because the title is the figure caption, and the figure caption goes underneath the graph. The other thing is, make sure, you see how there's a lot of white space here? I would change the y-axis from 4 to 8, so it then explodes those data points. Okay. Tables, again, table captions though are left justified, just a standard. And make sure you have units. So I don't know what the unit is on this. Is it raccoons? This voltage, I'm guessing, was VF. Okay, so make sure you put that. What's the unit on RT? It could be porcupines. And look, make sure, I don't know what that temperature, I've never seen that unit. So be very careful on your tables and make sure these are centered with sig figs appropriately. Don't have like something like that, okay? As long as you give us an appropriate significant figures, that's good, okay? Make sure you reference and you talk about each graph in the trends, okay? So here's resistance versus voltage. Tell us the trend that you see, okay? In this table, you have temperature, voltage, which is the raw data. So make sure you say that this is the raw data from the thermometer, from the voltage across the fixed resistor, and then tell us what equations were used to find RT in all of these. And those equations should be referenced back to your introduction. Okay? This is used with the voltage divider, and then this is the equation based on the thermistor on the data sheet, based on this. Okay? Down here, yeah, see, this right here should not be here. It should be down here. Okay? Now, make sure you're specific. It says measured voltage versus temperature in a voltage divider circuit. Okay? I would say this is actually backwards first. This is temperature. This should go first, right? It's temperature versus voltage. But what's the temperature of? Is it of the thermometer or is it of the resistor? And down here, what voltage is this? Is this probably across the fixed resistor? So make sure you specifically say those. Okay? Again, avoid we, us, I. Down here, this is actually, if you remember, a thermistor is exponentially. So linear is wrong. So make sure you do exponential fit. Okay, not a linear fit. How would you know this? Well, we know right now that a thermistor is exponential. An RTD, a resistance temperature detector, is linear. And we use a thermistor, so it should be exponential. The other way to find this is when you fit your equation, there's another option that says regression, R squared. When you do linear, second order, third order, polynomial, exponential, that R square value, depending, like the closest one to 1, usually it's probably 0.99, that means that's the best fit for those data points. Okay, so you have to use regression to determine that. But in this one, it should be exponential. And I'm okay if you didn't fit anything in this one. Okay. Make sure you center those in your results. Okay. You can have sample calculations, perfectly fine. Or it's probably better to put those in an appendix. Okay. You should never introduce new equations that you've used in your report or data in here. Okay. Unless you fit or you're creating a brand new equation, and that's part of the lab. Okay, just to point out, there's nothing in here, but I probably move this to the appendix. Okay, now appendix references. Okay, make sure you put the fritzing, you put the reference for the equations. Okay, and any other ones, but make sure that these are referenced back into your lab. You have to put in brackets, like maybe the link here, if you use the link, or the title of the book or the author. Okay? So the equations for the RTD and the thermistor come from a book, and I would use that as a reference. Okay? Appendices. In this particular lab, the first appendix I probably would put is the actual full data sheet for the thermistor. Okay, you actually need to put that in the lab. Okay, second appendix would be put all the notes that we talked about in class in here. Don't just say it, but they need to go in here. Okay, and then maybe appendix C could be sample calculations. So the big things that you need to know again is to headings. Make sure your figures are centered. Your figure captions go underneath centered. There's no titles on the graphs. The titles are the figure captions. Table captions go on the top left and they're left justified. The tables are. Make sure you have units. They're centered. Correct sig figs. Make sure if you put a graph in, you have to talk about that. You have to say in figure whatever shows temperature versus voltage for whatever. Tell us the trends, and if you fit something, make sure you fit and you show us regression values. Okay, your introduction talks about the main components that you need, all equations for the rest of the lab, because you then would reference back to that introduction. Okay, Procedures are not step by step. It's more of, here is the schematic, here is what we used, here is what we did. Not did, but here is, we're going to measure the temperatures, we're going to calibrate this from this temperature to that temperature, record the data every 2 minutes. Okay? Get into results and discussion. You talk about the graphs and the data, the table that you have. You reference back to say, okay, utilizing those equations shown in the introduction, we got this data. Okay? Make sure you save your file with your name in it. Make sure when I send you back stuff, that you highlight this stuff. You go to review, you go to tracking, accept this change, and then move on. Okay? I don't want comments back. I don't want red things back. I want you to approve those and change those and then send things back to me. Okay? Not sure what happened to my computer, but all right. I hope this helps, because I'm noticing a lot of the same things. Okay? Best of luck. If you have questions, let me know in the comments. Thank you.